review it at the beginning of this part. Again, when we do any of these problems, what should we always do with these points? Swap every time. Go ahead and -1/4. And make sure you label as well. So we have this quadrilateral line, and we need to determine if it's a parallelogram. We have this quadrilateral line, and we have to determine if it's a parallelogram. Right? And you have to do the math to support your answer. Even if it might look like a parallelogram or a rectangle, or rhombus, or a square, you have to do the math to support it. You just can't say yes, diagonals bisect, or whatever, and then move on without any math. You have to do it in order to get credit. Okay? So, kind of gave it away, but what do we know about the diagonals of a parallelogram? What do they do to each other? Do you know your question? Anytime your question. What do we know about the diagonals of a parallelogram? Not in every parallelogram, only certain kinds. Yeah, very good. They bisect each other. They cut each other in half. So what you're going to do, connect the diagonals. L and O match up. And if they bisect each other, that means they hit in the same point, which is directly in the middle of each of those diagonals. Okay? Well, how do we find the middles of the diagonals? What do we do? Find the, another word for middle. Midpoint. How do we find the midpoint? What do we have to do with all our x values? Add them together. So L and O match up. They're on the same diagonal. Here's L, here's O. We'll add up your x values. What are our x values with L and O? -1 and 4. Very good. Add them up. Then what do we divide by? 2. Right? Do the same thing with the y values. What are our y values with L and O? 4 and -3. Add them up. Divide by 2. Right? Well, what's -1 plus 4? Right? So we get 3 over 2. What's 4 plus -3? So we get that midpoint is 3 over 2 and 1/2. Those can't reduce, so we just leave them. Repeat the same process for the other diagonal, NI. N and I match up. It doesn't really matter what order you do it in. IN or NI, doesn't matter. Repeat that same process. Add the x values and divide by 2. What are our x values with N and I? 2 and -1. 2 plus -1. Divide by 2. What are our y values? 2. Add them up. Divide by 2. Well, what's 2 plus -1? Oh, thank you. Looking at the wrong one. What's 2 plus 1? 3. What is 3 plus -2? We can't reduce them. Did we get the exact same midpoint? Yes. So, this is a parallelogram. Yeah. You get the exact same midpoint. We know it's a parallelogram, so we say yes. And you have to justify your reasoning. So our reasoning is diagonals, and you can abbreviate the diagonals bisect. Okay? You have to have the math of showing that they have the same midpoint, and then you have to have that reasoning. Yes, diagonals bisect. If they're not the same midpoint, then your answer would be no, diagonals don't bisect.
Well, here's the nice thing about all these. You basically do the same process over and over and over again. All right, so you guys get pretty good at it. This is the first step in doing it all. First step, plotting, and then the first step is figuring out its parallelogram. If it's not, you can stop right there. You don't have to go any further. So let's try this guy right here. So we want to determine if this quadrilateral with those vertices is a rectangle. That's what we're looking to see. So let's go ahead. Let's graph this quadrilateral tiger. All right, so t, negative 3, 4. Negative 3, 4, right there, give me a t. Negative 1, 5, negative 1, 5, that's an I. G is 2, negative 1. G. And then R is 0, negative 2. That's an R. All right, there's our shape. All right, so is this a rectangle? Here's what some of you did on the test. Yep, it's a rectangle. Explanation, it looks like it. You're wrong. We got to do some work to see what it is. But just like I said a second ago, you do the same steps over and over again. First thing first, let's prove that it's a parallelogram. If it's not, is there any way it can be a rectangle? No, because a rectangle is a parallelogram. So we already have our answer. So let's analyze these diagonals again. So I'm looking at these diagonals, these nice little green right here. This is one diagonal. There's the other. So let's match those up. I'm going to say TG and IR. So let's find TG real quick. So TG. Let's find that midpoint of TG. T's right here. G's right there. Let's find the averages. Just going to divide by 2. Negative 3 is 1 of my x values. 2 being the other. Plus 2. My y value is 4 plus a negative 2 for the other one. 4 plus a negative 2. Simplify this a little. Negative 3 plus 2 is a what? Negative 3 plus 2. Negative 1, thank you, over 2. Over here, 4 plus negative 2, or 4 minus 2 is a... You guys looking at me crazy here. Did I mess this up? I did mess it up. And no one said a thing.
Yeah,
No one said a thing. Yeah, not negative 2. I don't know why you guys are letting me do this.
I just thought I was wrong.
Yeah, well, you don't think I make mistakes? You're right, I don't. That's a good point. I am pretty good. So 4 minus 1, negative 1 is what it should be. Woo, there we go. Okay, so 4 minus 1 now is a 3 over 2. All right, good, worked it. Did any of these reduce? Like evenly? Nope, we're good. Leave it like that. Now let's find the other one. We need to find, we found TG, let's find IR. IR, injured reserve. There's my I, there's my R. Let's match it up. It's a little slower here. Negative 1 plus 0, 5. Here's a negative 2. What is negative 1 plus 0? You need a calculator. Tabulate that. Negative 1 over 2. 5 minus 2? 3 over 2. Are they the same? Are these two values the same? Do they have the same midpoint? Then yes, they bisect each other. So guess what? These are parallelograms. All right, great. So it's possible that this is a rectangle. Now we have to know what it means to be a rectangle. What is the main definition of a rectangle? It's the thing that makes a rectangle a rectangle. Rectangles, what? Cough? No, that's incorrect. Yes? They are, but that can also go for a square too. There's other problems.
Two sides are longer than the other.
Possibly a square would have that. They would be the same side.
Any parallelogram.
Yeah.
Wait, how would a square be longer sides?
They wouldn't longer sides, but the sides, opposite sides would be congruent. Two pairs of opposite sides congruent. Yes, you. 4 right angles. That's the true definition. A rectangle has 4 right angles. But here's the nice thing. Because we proved that this is a parallelogram, we have a rule that says parallelograms, and if you have 1 right angle, how many do you really have? You have 4. So all we have to do is find 1 right angle. What right angle do you want to find up here? Let's check one of these angles and see if it's T. Was that a good one? Let's figure out if this is a right angle or not. It may or may not be. Well, how do you make things that are right? Angles, that I mean. Is there some sort of thing that makes right angles? Yes. The opposite reciprocals. You're talking about, you're looking at their slopes. If I make opposite reciprocals, they make these type of lines. What type of lines make opposite reciprocals? Starts with a P, rhymes with perpendicular. Oh, perpendicular. Good one. Nice job. So perpendicular lines, and we are looking at those opposite reciprocals. So if we're talking angle T, the two segments I'm going to look at are TI and TR. If we can show that those are perpendicular, that they have opposite reciprocals, then I know we have a rectangle. So let's find the slope of TI. Let's find the slope of TI. Well, if I go to TI, give me directions. How do I get there? How do they slope? Do I have to go up or down to get to I? I have to go down to get to I from T? I gotta go up, right? How much do I go up? 1. How far do I go over? 1, 2. So I went up 1, over 2. So I have a 1/2 is my slope there. Don't need to reduce it there. That's what TI is. Okay. Well, let's figure out TR. What are the directions to get to TR? What do I have to do? I do have to go down now. Let's see how much I go down by. 1, 2, 3, 4, 5, 6. Since I went down, what kind of 6 is that going to be? Negative. Negative 6 over, or over 1, 2, 3. Okay. 3. Oh. Yeah, these numbers are totally different. They're not the same, right? Can't be. Not a rectangle, it's a parallelogram. Is that right? The inflection of my voice says no. What should I do to this fraction? Simplify, reduce, very good. Negative 6 over 3 reduces to? Negative 2. Ah, that's a little better. So now look at these right there. Are they opposite? Is one positive, one negative? Check. Are they flipped fractions of one another? Remember, 2 is, or negative 2 is the same thing as negative 2 over 1. So yes. So now I can say, yes, this is a rectangle. And I can say it has 4 right angles. Again, because that's 1 right angle, it's got 4 because it was a parallelogram first time to prove. Questions on that? Just going to copy that down.
On the next one, we want to determine whether this quadrilateral is a rhombus. So again, first step, always plot those points. We have negative 5, negative 2, 1, 2, 3, negative 1, 5. It might be quite obvious right off the bat this is not a rhombus. Why? Just looking at it, does this make you think can't be a rhombus? What's special about a rhombus? What's one thing that's special about a rhombus?
When the bisecting line bisects on the are
Very good. The diagonals are perpendicular. That is true, but that's what we're going to use. Visually looking at that, what makes you think it's not a rhombus? Just visually. What we know about all the sides of a rhombus, they're all what? The same. Looking at that, does it look like all the sides are the same? No. So that should be an indicator to you that this is probably not a rhombus. But you can't just use that as your reasoning. Okay? You can't just say, no, not a rhombus, because none of the sides are the same. Not all the sides are the same. Well, okay, you can use that, but you have to show that using math. You can't just do it based off what it looks like. You have to do the math to back up your answer. So what we're going to do is, Alexia said, we first have to show if it's a parallelogram. Then we're going to show that the diagonals are perpendicular. Okay, so the very first step, just like all the other problems, make your diagonal. So B matches up with what? B matches up with A. So we're going to find BA. Add those x values, and I get this. Add those x values up, divide by 2, do the same thing with the y's. So x, -5 and 3, add those up, divide by 2. Same thing with the y's, add those up, divide by 2. What do we get when we add those x values together? -5 plus 3 is? -2, very good. And what do we get when we do -2 plus -1? -3, very good. What does -2 over 2 reduce down to? -1. 3 over 2 can't reduce, so just leave it. Okay. Well, do the same thing with the other diagonal. E matches up with R. Oh, repeat that same process. E and R match up. Add the x values, divide by 2. Add the y values and divide by 2. 1 plus -5 divided by 2. Oh, don't do that. 1 plus -3 divided by 2. And 2 plus -5 divided by 2. That's a minus sign. So what do we get when you're 1 plus -3? What does that give us? -2. And what we do when we get 2 plus -5? -3. And again, we just said up there that -2 over 2 reduces down to -1. Is this a parallelogram? Yep. Because our midpoints are the same, we can keep going. If you thought that they weren't the same, then you know to stop. Because if it's not a parallelogram, it can't be a rhombus. We're going to keep going. So we are going to show at these diagonals whether or not they're perpendicular. So you just count up and over to find the slope. We'll start with BA first, it doesn't matter. So we're going to count up and over. Up and over. How far do we go up? How far do we go over? Slope of BA is 1 over 8. Alright, well let's find the slope of ER. So count up and over. When you find the slope of ER, how far do we go up? 7. How far do we go over?
point.
Are these opposite reciprocals? Oh, so can this be a rhombus? No. So yes, looking right off the bat, no, it's not a rhombus. But you have to do the math to support your answer. Diagonals are not perpendicular. So it can't be a rhombus. Questions over that? Similar processes every single time.
Good. Great. Moving to this guy. Quadrilateral, oh my. None of you like that. None of you enjoyed that. Justify a reason for all the following. Determine if oh my is a parallelogram. Still nothing. You don't appreciate that humor in that. All right, whatever. We had lion, we had tiger. Oh my. All right, I guess you got nothing here. So let's graph this out. So O is at negative 1, 4. Negative 1, 4. O. H, 2, 5. H. M is at 3, 2. 3, 2. M. And 0, 1 is Y. And we'll connect those dots. Alrighty. Well, notice they're divided into 4 different sections here. Well, we're going to determine if oh my is a parallelogram. How do you determine if oh my is a parallelogram, or what do you need to do? Shane, yes. Find the midpoint. It's the first step we've done every single time. You guys should be pros at it. So I would have find it.
What if that one of the simplest shapes would be one of the most annoying?
You are right. If we're trying to prove all these things, you're correct. I don't know about annoying, but time consuming. Don't have a shade can be.
I just consider like just doing a bunch of tasks and just dragging, just doing like a ton of tasks instead of it being like particularly.
I get what you're saying. Sort of quick and you're done. Like a lot of people do real quick. I get it. So we're going to look at the diagonals, like you guys said. So we're going to look at OM, find that midpoint, and we're going to find the other one is HY. Find that midpoint. Let's go. Divided by 2. I'm just writing this out. You guys start filling stuff in. So OM. So if I go O and M, here's my O, there's my M. Write them together. Get the X's first. My first X is a negative 1 plus my second X is a 3. Going on to the Y's, I have 4 plus a 2. Let's simplify. Negative 1 plus 2, or 3, excuse me. Negative 1 plus 3. I said to you. So it's 2 divided by 2. 4 plus 2 is 6 divided by 2. I need to reduce both of these. What's 2 over 2 reduced to? What? 6 over 2 reduces to 2? What's out of 6? 3. So I got 1/2 on that one. Let's do HY. So here's my H. There's my Y. Plug it in. First X value, 2 plus second X value of 0. Y value of 5 plus Y value of 1. 2 plus 0 is 2 over 2. 5 plus 1 is 6 divided by 2. And I realize you guys look at this step right here. You say, yeah, I know it's good. Yeah, you're 5. So it's going to be 1/3. So is this a parallelogram? Yes. So I can say yes is a parallelogram. And my reasoning would be diagonals bisect. Great. Awesome. And you guys should be pros at that because that's the first step you do at every single one of these. You check to see if it's a parallelogram. If they're not the same, then it is not a parallelogram. No need to go any further. But because this is a parallelogram, we are now going to determine if this is a rectangle. Well, we've done that already, so you guys know what to do here. So it's a rectangle. What does it mean to be a rectangle? Rectangles have 4 right angles. Since I know it's a parallelogram, I only have to find one of those right angles. What right angle do you want to find? Anyone, Colin, pick an angle that you want to find. H, good call. Who wants to find H? So he said H right there. Let's find H. Well, we're going to look at those lines that create H. So there are 2 sets of lines that make it. OH and there we go. See, someone got it. I'll have that for the record. Last period, no one said that, so just let that know, camera, microphone. So that one and the other one of HM. Those are the 2. Let's find those slopes. All right. Let's find OH first. So how do I go from O to H? What do I need to do? How do I get there? Give me directions. I have to go up or down. Which way do I go? Up. Up 1 over 3. So since I went up 1, it's positive. Over 3 positive direction, it's 1/3. Well, let's do HM now. HM. Is that a store? Like it is. How do I go from H to M? Do I have to go up or down? H to M, what do I have to do? Down. 1, 2, 3 over 1. So since I went down 3 over 1. Look at their slopes. What do you notice? They're perpendicular, they're opposite, they're flipped, all those things. Fantastic. These are opposite reciprocals, therefore they're perpendicular. Because these are perpendicular, that makes a right angle. Because we have a right angle, we now have a rectangle. So I can say, yes, it's a rectangle because I have 4 right angles. I got 1, I got 4. Big sale going on. C, determine if OI is a rhombus. What do we need to look at to prove rhombi? Rhombi have this. Yes. The diagonals create right angles. Very good. So we have to look at those diagonals again, find the slopes of those diagonals, and then we'll see if they are perpendicular, or excuse me, they're opposite reciprocals. These are perpendicular. That means we have a rhombus. So the diagonals together, the same one we had earlier. We have O, M, and we have H, Y. All right. Let's do OM first. How do I get from O to M? What do I need to do? How do I get that level? What do I need to do? Up or down? Down. 1, 2. 1, 2, 3, 4. 4. I don't know why I went over 5. 4. So I went down 2 over 4. Always reduce that. What is negative 2 over 4? Negative 1/2. Awesome. Let's do HY. Let's go left or right. Doesn't really matter. How do I go from Y to H, though? What do I need to do? I have to go up or down? Up. 1, 2, 3, 4. 1, 2. So I went up 4 over 2. Up 4 over 2. That needs to reduce down as well. This will reduce down to a 2, or 2 over 1. Looking at these slopes, are they perpendicular? Yes? There's a lot of head nodding going on microphone. I want you to know that. All right? Yes, they are. Because I have opposite reciprocals. It's one negative, one positive. Yes. Are these fractions flipped? Again, remember 2 is the same thing as 2 over 1. Are they flipped to one another? Yes. So guess what? I can now say, yes, this is a rhombus. And I would say the diagonals perpendicular. Diagonals perpendicular. The last thing, is this a square? Is it a square? Ooh, it is a square. I hear some yeses. I hear some people falling asleep. How do I hear it? I just know. It is a square. Why is it a square? Because a square is the baby of 2 other different shapes. All right, if you did a little flow chart, they flow down to this shape. Because a square has all the properties of a rectangle. All right, so I would say, yes, square, because it has 4 right angles. And the diagonals bisect one another. If it has both properties of a rhombus and a rectangle, then it automatically is a square. A square possesses all properties. Parallelograms. 1 right angle, 4 right angles, angles bisect, congruent, diagonals congruent, all that stuff. So that's it. So yes, Jason, there's a lot of work just to prove a square, which is probably the most simplistic of the shapes. Drawing. A lot of work. It's good to know.